This is the solution to problem number 8 on Fall Exam 2017. Let's start with, what's the problem? We're looking at reflectors put on two positions of a bicycle wheel at different locations on the spoke at radii R1 and R2. And what do we know about the problem? Well, we're given that the ratio of R1 to R2 is K. We also know, since this is a rigid body that's rotating, omega at all radii at all points is going to be the same, so omega 1 equals omega 2, which equals omega. We're also told that omega is constant, and so we know that the tangential acceleration is 0, and the radial acceleration is equal to v squared over r. Finally, we know the relationship between linear velocity and angular velocity. V is equal to omega r. In problem I, we're asked the ratio of v1 to v2. We can write these in terms of their angular variables, so that would be omega r1 over omega r2, and since omega is the same in both cases, the omega cancels out, and we're left with r1 over r2, which we know from what the problem gave us is equal to k. Finally, we're asked the ratio of a1 to a2. This is equal to v1 squared over r1 divided by v2 squared over r2. If we write this out in terms of angular variables, we have omega r1 squared over r1 divided by omega r2 squared over r2. We get the omega squared, and then the r1 squared and that r1 cancel, so we get omega squared r1 divided by omega squared r2. And since omega squared is the same in both cases, it cancels out, and we're left with r1 over r2, which again is equal to k.